Okay. We left off Friday looking at the brute force algorithm, which was listing out all of the possible ways, getting every total, and then picking the most optimal. We then went from there to nearest neighbor algorithm, and you all told me that was a problem because we didn't have the optimal circuit. So they sat back and said, is there a way we can improve it because we like how efficient it is to do nearest neighbor? And they said yes. And their way of fixing that is called the repetitive nearest neighbor algorithm. So what you're doing is the same thing, except we're going to do the nearest neighbor for every vertex. Okay, so you're going to do nearest neighbor starting at A. Then you'll do it again starting at B, starting at C, starting at D, until you've exhausted all of your options. Okay, so we're going to perform the nearest neighbor algorithm for every vertex of the graph as the starting vertex. That second blank is starting. Okay. Once you've listed all of these, you're going to then compare your circuits and choose the circuit with the least weight. You're trying to find the optimal. And then if we need to, you're going to reorder or shift it to start where they tell you to. Okay. So that jumps us into this example. So if I started at vertex A, who is my nearest neighbor?
B.
B. Okay, so A to B, and that had a weight of 9. I'm now at B. Who's my nearest neighbor? D. And that has a weight of 13. And then I have to go to C, because remember, we have to go to every dot for Hamilton. So I have to go to C. That has a weight of 11. And this is a circuit, so I must go back to home, which is 15. What does that give us for a total?
48.
So what?
48.
48. Okay? Because we're unsure if that's the most optimal, we're going to do it again. But this time, I'm going to pick B to start at. Okay? So if I start at B, you said my nearest neighbor was A. Okay, so B to A, that's 9. If I'm at A, my nearest neighbor then is
D.
D.
10.
10.
11.
And then you have to go to C, so yes, there's 11. And then we always go back to the start. This time we started at B, so there's 17.
$47.
47. Okay. We're going to do the same thing, but this time I'm going to start at C. If I start at C, my nearest neighbor is
D.
D. There's 11.
Go over to A.
You said then go over to A. That's 10.
B.
I then have to go to B because I haven't been there yet.
Get back to C.
And then back to C.
Get
47 again. Okay. We've got one more vertex to start at. We have to start at D. Nearest neighbor.
A.
A. 10.
B.
You said B. 9. Must go to C. 17. And then finally back to D,
11.
which is 11. And you said what?
47.
This one's 47 again.
No, 47.
Okay. So now, they want us to pick the optimal circuit. What's your choices?
B, C, D.
Any one of these three would work. Okay. Your last step, though, final answer must start at A. So you're going to take any one of these three that you have and just rewrite it to start at A. So if I start this one at A, it becomes A, D, C, B, and back to A. And it had a total of 47. You must rewrite it to start where they're telling you to. Or I could rewrite this one starting at A. A, B, C, D, and back to A. It's still 47. Did you notice though? A, D, C, B, A. What did this one be? It's the reverse. Okay. If you actually reorder this last one too, you get the same thing as this one, A, B, C, D, and back to A. So any one of those answers would have been correct. This is also why when you're trying to find all of your distinct circuits, you start at one letter. Because if you didn't, these two are exactly the same thing. And then you'd be missing out on circuits. Questions? What do you think is difficult about repetitive nearest neighbor?
Writing up the.
It's going to be a pain. The more vertices you have, the more ways you have to do it.
Yeah.
Okay. So, what do you mean, not really? I mean, I'm not saying it's not, but heaven forbid we get to this one.
Wait, how many,
You've got 7 repetitive nearest neighbors to do.
how many did that number 10 have? No worksheet.
Well, so y'all should be experts on this, right? Okay, so this one, you can either do from the graph. I gave you the graph. You can put your numbers up there where they belong, or you can do it straight from the chart. Does not matter to me. Okay. So, y'all want to label the graph, or you want to just use the table? Let's just use the table. Okay. So, we've got one that's got to start at A. If I go to A, what's my nearest neighbor? My nearest neighbor is C. So, I've gone from A to C, and that was 119. I'm now at C. My options are B, D, and E. They're the only ones that I haven't circled. You said we're going where? E. Perfect. Okay. That was 120 plus. From E, I can only go to B or D.
D.
200 or 199. So you're going to take D. From D, I have one more stop I have to make. I have to go from D to B, which was 150. And you always have to go back to the beginning. So B to A is 185. Left on the desk.
773.
773. Juan, where's your notes, my friend? Okay, I need to do it again. This time I need to start at a different vertex. So let's start at B. If I start at B, who's my nearest neighbor? So B to C. I agree. 121. Okay, so we've gone B to C. From C, I can either go to A, D, or E. Where are we going?
A.
A. A is 119. From A, I've got D or E left to look at. E. 133. We must then go to D, which is 199, and we must go back home, and D to B is 150.
12.
I got higher than that
Yeah.
last time.
I did one.
722. Okay, 722. We do it again. This time, I'm starting at C. If I start at C, my first stop should be A, 119. My next stop then, from A, I can go anywhere but C. E, 133. I'm now at E. I can either go to B or D. D, 199. And you said to B then, because we have to go to every stop. And from D to B is 150. And then finally back to C. And B to C is 121. $722 again. Okay. I need to do the same thing and start at D this time. If I start at D, my first stop is B, 150. From B, I then want to go to C, 121. From C, I either can go to A or E. A, 119. Must go to E then, and A to E is 133. And must go back home. E to D is 199. 722 again. I'm getting lots of 722. One more. We're going to skip the next example. I think you've gotten the point. So my last one. We're going to start at E. From E, my first stop is
C.
C. Good. 120. I'm now at C. A, 119.
And then you go to E.
Careful. We've been A, C, and E.
Oh, okay.
B or D. I want to go to D next, 152. That's why I circle them on the chart so you know where you've been. Okay. From D, I have to go to B. So D to B is 150. And from B, I have to go back to E. And B to E is 200. You said what? 821. So if I asked you to pick the optimal circuit, what would you pick? Any one of these three. Okay? It says, though, I need to start at C. Well, guess what? You already have one that starts at C. Why not use it? You could have always rerouted B and rerouted D to start at C. But if you already have one that starts there, why not just use it?
Reroute B, you get the same thing.
There you go. C, A, E, D, B, C. Yeah, they are off. These are just all shifts. Okay, so the last one. This is my favorite. The last algorithm I have for you is called the cheapest link algorithm. Your goal here is going to be to piece together a Hamilton circuit by individual edges or links by trying to choose the smallest or cheapest link first. Okay, so here's all of your steps. Step 1, you're going to pick the edge with the smallest weight. Anywhere on the graph, you're going to find your smallest number. You're then going to mark that edge. I don't care if you highlight it, whatever you need to do. Step number 2, you're going to pick the next cheapest edge, and you're going to keep going until all of your dots have 2 lines coming out of it, except for 2. Okay. Things you cannot do. You cannot close a circuit. Do not close a circuit. Okay. You also do not want more than 2 lines coming out of any dot. And if you have ties, if you have 2 lines with the same number, you can pick and choose all you want. Okay. So, what I mean by that, here we go. Let me do this so I can get my highlighter here. Okay, looking at this graph, I want you to find the smallest number possible.
15.
13. So you're going to take your highlighter or your pen, whatever you have, and you're going to draw a line. Okay, I prefer highlighter at this point. By all means, if you would like to borrow one, please grab one. Just make sure you put it back and you don't keep it.
I got one right here.
Oh.
Oh, Miss Miller. I ain't gonna be here Friday.
Miss Benchmark.
Are we just
Are we just what?
using these because we're having so?
I think it's easier to do it this way so you can visually see everything right. Okay?
It's a cold.
Okay. Once you pick your smallest number, what is my next smallest number?
15.
15. As long as you don't have 3 lines coming out of any of these vertices and you're not closing a circuit, we can use 15. So 15 is good.
You said that we're not what?
You cannot,
So right now, we can't go A to G.
like, I can't draw another line coming out of F because I only want 2 lines coming out of any dot.
Okay.
Okay. I also cannot connect A to G because that closes a circuit.
All right.
You want to leave it open. You need to touch every vertice. So 15. What's my next smallest number? 20.
You see 20, yeah.
Oh, never mind.
It's 28.
No, it's 20.
Oh, I think you meant from A.
We're not.
No. Don't worry about anything else you've already highlighted. Always smallest number anywhere on the graph. Okay. It'll all come together, I promise you.
All right.
Okay, so 22 would be my
Can't do
next
it.
one. But again, I can't do it because I can't close off this circuit.
So
I want to leave it open. So we skip 22.
28.
28. Okay, I have 2 of them. I've got one here and one here. Can I use them both?
Yeah.
Yes, I can. I only have 2 lines coming out of G, so that one's good. I can also use this one. I've got 2 lines coming out of A now and 2 lines coming out of D. What's my next one?
29, but you can't do it.
29. Okay, I've got 30 here,
30 at top.
but I've got a 30 up here. I can use this one. Okay. Biggest question, how do I know when to stop?
When you touch
You
it.
hit all the vertices.
You've hit every vertice now.
So that's
Every vertice has been hit twice except for 2. Which ones haven't?
B and E.
B and E. So your last step then, close it off and create your circuit.
Well, you kind of look a little.
What?
Oh, it goes.
Kind of looks like a what?
What?
Huh? Okay. So now, it says we need to start at G. So if I start at G, where did I travel to?
F.
F. Then I went to
A.
A,
B.
D,
E.
E,
B.
B,
C.
C,
G.
G. The last thing you then need to do is add up all the numbers that go with it. So we had a 13, a 15, 28, 28, 30, 20, and 80. I don't need you to write them down if you don't want. You can just circle them and then add them together. And you got what?
194.
Should be more than that. If you need to write them down, Trey, we've got 30 plus 28 plus 28 plus 20 plus 80 plus 15 plus 13. You should end up with 214. So not only am I gonna be looking for the actual circuit itself, I'm looking for that total. You must give me that total. Cheapest link from a table is probably my favorite.
It's always gonna work out when you do it. So.
So here's cheapest link from a table. My suggestion to you, when they give you the table, I want you to visually create your picture. So the first thing I want you to do is draw all of your dots that are available in your table. So draw yourself an A, a B, a C. You can put these anywhere you want. I don't care. E, F, and G.
A to F.
Also, remember, what's up top here and across the diagonal are the same exact numbers. So don't confuse yourself. Go ahead and cross out one of those sets of numbers. That way you're not doubly looking at everything because it gets confusing. Okay, so I always cross them off. Okay, so now, taking a look at that section of your table, what's your smallest number?
13.
13. 13 connects F and G. So there's your line.
Then A to F.
Okay. Then Saphir says, my next smallest number is 15. And that should connect A to F.
You can't do F no more.
You can't do F anymore. You already have two lines coming out of it. So anything connecting F is out of the picture. What's my next smallest number?
D to E.
D to E. There's a 20. This is why I like to draw the picture itself too and connect the dots because you visually just saw I cannot use F anymore.
A
Okay.
to D.
You said, what's my next smallest number?
It is 22, but you can't use it, so it's 28.
Why can't I use 22?
Because
You can't use.
It's G and A.
Oh, no.
Yeah, it closes the thing.
It closes the circuit here,
Come on.
okay? You cannot use 22. So you said my next one available was
But it'll be
28.
B to C. Well, yeah, that one.
A to D. So now I can't go back to A anymore.
Or D.
A or D. Okay, you said we have another 28.
It's a
C to G.
So you
C
can't
to
use-
G. You can use that one.
Yeah.
That one's still good. Now G is out of the question.
B to C.
Okay, so my next number would be,
B to C. 30.
because you skipped 29, because you can't do D to C,
B to C.
30, B to C, because we can't do 30 D to F. Okay, so we went here. So B to C.
Yeah, connect B to E, right?
Okay, everything has been connected by two lines except for B and E. So you want to go ahead and close it off. Don't forget though, when you close off B and E, you have to come up here and find your number that connects B to E. If you miss that number, you're going to be way off. So then the last thing they want us to do is they want us to go ahead and do this starting at G. So we're going to start at G. If I start at G, where am I going? C or F, it doesn't matter. So let's go C, G to C. Where does C lead me to?
B,
B,
E,
E,
D,
D.
A, F, G, C. Oh,
You started at G, you're fine. Okay, you could have written that backwards. G to F to A to D to E to B to C to G. It doesn't matter. The last thing you want to do now is go back and count up all those numbers that you highlighted or circled or whatever you did.
214.
And you should end up with 214 because guess what? That chart is the same thing as the graph that we just did.
That was 58.
We've got 2 more and we're done. They're smaller ones. Okay, example number 2. They want us to start at B. Okay, what's my smallest link?
Oh, wait.
9 is my smallest. So there's 9. What's my next smallest?
19. Oh,
12.
17. Oh,
Well,
see 12.
okay, that's where it's going to trip you up, especially when you have a huge graph. It's like, okay, there's a million numbers here, there, and everywhere. I prefer the table. That's just me.
Then 17.
Okay, and then you said 17. I can still do that.
Then 19.
I can do 19.
Me and Aaron.
Then another 9. Oh, nope. Can't do that. 20. Nope.
24.
21.
20.
20. Oh, dang. 20. Oh.
27.
33. No, you can't do that one.
29. Look,
Yeah,
have I
they all
touched? Have I touched every dot?
Yeah.
Yeah.
Yes. The only 2 that are open are B and D, so we connect them.
I was just testing the story.
Okay, so it wants us to start at B. B to
A.
A
E.
to E,
C. D.
C, D, and back to, E. Sorry, not A. Okay, and then you want to add up all your numbers. B to A was 19, plus A to E is 12, plus 17,
9.
plus 9, plus 29. The 86. Double check and make sure you plugged it in with the calculator. Somehow I'll get super lazy. Just push buttons.
Miss Smith, you came to work yesterday?
Yes, I did. For a whole whopping. I got here probably about 9. And Miss Curry kicked us out about 10:30.
I'd have been mad.
I don't care. I got paid for a whole day.
Oh, yeah, the game then.
Right.
I'd have came for 30
Right.
minutes. So.
Okay. Again, the last one. You have a table. So draw yourself that visual picture so you can say, I can't go back to B anymore. You don't have to make it big. It doesn't have to be big. Just enough that you can connect your dots. Okay.
Oh, no.
What's my smallest number? Oh, don't forget to cross off this other part of the table. Don't let it confuse you.
And 119.
You said 119,
C to A.
and that's C to A. So 119, C to A.
120.
You said 120 is next. That's C to E.
And 121. Oh, no, that's B to
B
C.
to C. No, that won't work. Right.
33. Nope.
A to E won't. Okay. So I have to skip 121. I already have 2 lines that come out of C. We also have to skip 133 because A to E closes a circuit. I don't want to do that.
150.
So 150, D to B. You can't connect it yet. You only have to have 2 open ones.
So you go 52.
A to D. Okay, 152 connects A to D.
And then
Now you have 2.
made a star.
So E to B. We made a star. Don't forget to go back and highlight your E to B. Okay, so then the last thing we need to do is list it out. They want us to start at D this time. If I start at D, I'm going to B, B to E, C, A, and back to D. And then you're going to add up all 5 of these. So 119, 152, 150, 200, and 120.
741.
741. Questions? Let's go home. It's not quite that time yet, is it?
I know you don't feel like doing this homework today.
I know you don't want to write a paper.
Right. Everybody got a homework pass anyway.